Hi, my name is Vaibhav Khandelwal, and I'm the Senior Product Manager with the Database Migration Services team in AWS. With me today, I also have Sam Kannan, who is a Director of Cloud Architecture and DevOps at Eris Global. Let's jump in and see what we have for the agenda today. First off, we'll talk about what are AWS DMS and SCT services. If you haven't seen these products or haven't read about these products, this will give you a good intro to what they are all about, new features we have added so far, and followed by a product demo. Once I'm done, Sam will walk us through their journey with AWS DMS. Then we'll be talking about some additional resources, followed by Q&A. Let's start with some of the basics. Why would you migrate? Your hardware might be nearing the end of its operational life, lack of redundancy. You don't have a feature called multi-availability zone. Maybe a good reason to look at the AWS cloud. AWS manages all of the infrastructure for you, from power and low-level hardware through networking, storage, and CPU, ensuring your applications and databases are always available when you need them. With AWS, you can scale your instances up and down as required. This covers both CPU and storage, but also offers specialized instances for specific workloads. In databases, AWS offers Aurora, which offers you read replicas that you can scale to the level you have never seen. Generally speaking, and overall, things are just engineered for the cloud. Pay only for what you use, turn it on, turn it off, scale up, scale down. We also champion in open source technologies, and those savings get trickled down to our customers. And it's fully managed, so you can save on labor and allow you to focus on what differentiates your business. As AWS deploys new features, you get them automatically. It can range from security patches through to new functionality. Let's look into what AWS DMS and SCT services are and how you can use them. Our goal with DMS and SCT is to allow customers the freedom to choose the best data platform for their needs. SCT makes heterogeneous migrations predictable, that is, the effort to move your commercial database engine to an open source database target engine in AWS, and for homogeneous migrations where you want to keep the underlying database engine like Oracle to Oracle, SQL to SQL. It will tell you the effort to move those to RDS as a managed service and still keep meeting the SLA of your applications. Once your assessment and planning phase is done, SCT can also help you automate your migrations. For example, your database may have secondary objects such as stored procedures and functions, which can run into hundreds or thousands of lines of codes. SCT attempts to convert those into proprietary language into the target engine, so you can accelerate these migrations as you go on from one engine to another. Once that is done, you can go on to use fully managed service called DMS that helps you easily and securely move your database and migrates your database from one location to another in near zero downtime. It has the ability to do a one-time bulk load, apply all the cache changes that it's collected during bulk load, and eventually keeping the target in full consistency with the source. So you can cut over your applications to the new database in AWS without any downtime to your customers that are being serviced by our app. Let's dive a little bit more into the use case. In short, it's a two-step process. One is you go in and prep your database. Let's say you are switching engine, so you would want to create an empty database using SCT and have a converted schema available in the target in open source, in RDS or in EC2 by itself. And once you have empty database, you go in to move your data using the DMS. We also have support to move on-premises data warehouses to Redshift in AWS. You can use data extractor agents with SCT that can be installed closer to your data warehouse on-premises, so they can move to S3 and eventually copying into Redshift. It's been a fairly successful product since its launch in reInvent in 2015. To this day, we have over 500,000 databases migrated to AWS. And this number keeps growing on a very regular basis. We have some big enterprise customers who have used this product, so it's been pretty popular. Now let's look at one of the first and most important phases of a migration. How do you plan and assess migration? How do you look at the viability of a migration? You will have to do a couple of things. That is, look at the database migration assessment report to understand how easy or difficult is the migration. Then do the actual conversion, which is what we are going to talk about in this section. Let's talk a little bit more about SCT. Like I said, it helps you to make heterogeneous migrations predictable, helps you with database code conversion tasks, but what SCT has the ability to do today is, it can look at your embedded SQL in your application code and convert it to be able to work with the target engine you are going into. Among other things, it can convert data warehouse schemas. It can even optimize schemas in Amazon Redshift. So it can look at your Redshift workload and see if you are using right sort and distribution keys in your Redshift cluster, and give you detail around what to change in order to improve performance, in order to go and follow the best practices for Amazon Redshift. Like we also said, that we also have support for data extraction agents that ships with SCT, which can sit closer to your multi-terabyte data warehouse with the ability to orchestrate the entire flow of moving into S3 and eventually moving it to Amazon Redshift. We also have the ability to convert your ETL jobs through SCT. For example, Teradata BTIC scripts, SQL SSIS, and Oracle Data Integrator scripts, and move them to PySpark jobs in AWS Glue that work hand in hand with Amazon Redshift. So you can manage your ETL pipeline as a serverless solution with AWS Glue. When it comes to AWS SCT product highlights, you have assessment reports, assessment of migration compatibility of source databases with open source database engines such as RDS for MySQL, RDS for PostgreSQL, and Amazon Aurora. It can recommend best target engine, provide detailed level of effort to complete migration, determine if you can migrate from enterprise to a standard edition license. It can convert your schema and code. It attempts to convert all schema and code objects to the target engine, including stored procedures and functions. It can scan and convert embedded SQL statements in app code. It can generate a report with the recommendations. It can also extract and migrate data warehouses to Redshift. So it extracts data through local migration agents. Files are loaded to an Amazon S3 bucket and Amazon Redshift. Some of the major data warehouses that we support today are Netezza, Vertica, Greenplum, Teradata, Oracle, and SQL Server. Here's how the assessment report looks like. All you need to do is install SCT on your laptop or an EC2 instance, and you connect to source and target database instance and run an assessment report. The assessment report will clearly tell you what it takes to migrate, how much of the database is convertible, and what needs manual conversion is seen in terms of action items that you see on the right hand side of this screen here. As I mentioned previously, SCT is also shipped with data extractors that help you with migrating your data warehouse to AWS. There are different on-premises data warehouses, and SCT supports today with abilities to move into Amazon Redshift. The data extractor agents optimize the entire flow. They unload data into CSV files on the instance the extractor agent is hosted or running. It compresses those files, it uploads it to Amazon S3 bucket, and copies it to Amazon Redshift. The previous step before this is to as with any heterogeneous migration, is convert the schema, create tables in Amazon Redshift with the right distribution style and sort keys. Once the conversion stage is done, you will have an empty database on the target. Now it's time to move the data, migrate your database to the target database instance. Here is all the supported sources and target databases that we support in DMS today. Obviously, this list keeps evolving as we add new source and target support in DMS. You can check our documentation to see the complete list of supported databases. We are in relational database space, so you can move Oracle, SQL Server, SAP ASE, DB2 LUW. We are also into NoSQL space, so you can move your MongoDB and DynamoDB databases to Amazon DynamoDB. Build your data lakes using Amazon S3, and then all data warehouse sources can be moved to Amazon Redshift using data extractors. Let's explore how it is that DMS can enable near zero downtime migrations. Assume you have a set of application users connecting to your on-premises data center. The customer starts by launching a DMS replication instance in their AWS account. The replication instance is basically an EC2 instance with replication software installed on it, but you don't connect to it in any shape or form, as we manage it for you. Then the customer provides database connection information to connect out to their on-premises database and into their AWS database. Next, the customer will select which tables, schemas, or databases they want to migrate. And DMS will load the data and keep it in sync on an ongoing basis. We also have full CloudWatch integration, so you can see how latent your target database is. And once your database is in full sync, you can switch your application users to use the new target database in AWS. Once the tables are in the system, the whole concept of change data capture or CDC will happen. The DMS instance will start watching your source database, and as transactions are flowing into it, it knows the last synchronization that it did with your target database and any new transactions that comes into it. It will then replicate those over to the target instance to make sure it is all synced up. In order to do this, it's looking at the transaction logs on your source database. Let's look at some of the DMS product highlights. Security is of the highest priority, and DMS uses all of the AWS security best practices in terms of VPC security. In terms of compliance, we are PCI, FedRAMP, SOC compliance, to name a few of our compliance certificates. All the data stored is encrypted using KMS keys. We have the ability to validate the migration before even it starts, as well as validate the migration as it runs. So before it starts, you can look for unsupported data types. It supports several levels of integrations. For example, you have the ability to move into Snowball Edge appliance and then move into AWS. You can also use CloudWatch to monitor your migration tasks. And it's also a fully managed service. Just in case it wasn't abundantly clear, DMS can move your data from pretty much anywhere to pretty much anywhere, sort of like a courier company in the cloud. You can use it for migrations from Oracle to Oracle. Probably better to use data dump. DMS's real power is going between engines. So that second example, SQL Server to Aurora. One exception I can think of, sometimes a native method doesn't offer ongoing replication. So say you are going from on-premises SQL Server to RDS SQL Server. The best way to do that is to take a backup file, export and import into RDS SQL Server through S3. But there's an outage while that migration is happening. And you know transactions could still be happening on your source system. So you could do that in conjunction with DMS replication feed only. Not the full load and just the replication to keep those changes in sync. Good ways to mix and match. You can fan out into a microservices architecture. So you have got big old monolithic OLTP system and you are looking to split it into microservices to build a new, more scalable architecture for flexibility. You can use DMS to bring data from certain tables, so you can even fan in data using DMS. MySQL shards into single Aurora instance is a good example of fan-in. Some very important use cases. We talked a lot about modernization use case, like moving your commercial database to Amazon Aurora. We have customers who use it for migration and replication use cases, and we talked about most of these use cases that you see on the screen. But we do have customers in the migration use case archiving old data for compliance purposes into S3. Being a heterogeneous logical replication service, we also have customers who have moved from relational to NoSQL or vice versa. From replicate perspective, we have customers who run analytics in the cloud. They move from OLTP sources to sources like Amazon Redshift to take care of their analytical use cases. They use this service to hydrate data lakes. They create data lakes in CSV or Parquet format in Amazon S3 from multiple sources we support. They create read replicas and also a bunch of streaming use cases to Kinesis with abilities to transform data as you go from one place to another and get your data in JSON format to Kinesis. Now let's talk about some of the new features that we have added in both AWS DMS and SCT. We have added support for several new instances in DMS across all the AWS regions, including AWS Classic and China region. One of the ways to keep up DMS and SCT up to date is by adding support for new source and target databases. Here are some of the new source and targets that we have added. Especially in SCT, we have added Babelfish as a new target. In DMS, we have also updated the versions of some of the sources that we already support. We added a feature in DMS that allows you to segment the collection of MongoDB cluster automatically and then migrate the segments in parallel. And also you can migrate multiple databases in one single task. In SCT, we made several Teradata to Redshift conversion improvements. We also added support for multi-server in a project in SCT. We also made several security related improvements in DMS that makes your migration to AWS more secure through TLS and SSL encryptions. With that, I'll show you the demo on how DMS and SCT both can be used to migrate your databases over to AWS. Okay, let's look into the demo. So how you can use DMS and SCT to move your on-premises Oracle database over to OLTP source in AWS, which is Aurora Postgres. That's what I'll be using it for the demo today, and to Amazon Redshift because I want to do some analytics on certain pieces of my database. So here what I'm showing you on this screen is a simple database which I'm using for the demo. It's a simple table that's showing me the name of the artist and the artist ID. Obviously, this is too simple of a database, but in fact, this can be easily scaled. So if you are moving your on-premise database, very complex database, the way you use it is exactly similar to how I'll be showing you how you can create tasks, how you can create migration tasks, how you can assess your schemas. So let's jump into it. So here's my database. Now, the first thing I want to do is I want to assess my database for the source and the target. So here, SCT being a desktop application, it's installed on a local host here where I'm doing the demo, and now it launches SCT. So in SCT, the first thing I'll do is I'll create a project. So creating a project is very easy in SCT. We have actually added a new feature around that. Prior to this feature, which I'm going to show you now, if you are trying to move multiple schemas to different target instances in AWS, you would have to create multiple projects in SCT, in AWS SCT. With this new feature, I can create multiple mappings of my schema into different target instances in AWS within a single project. Let's create a project. So here, the first thing I would like to do is add a source. When I click on add source, it shows me all the available sources that are supported by SCT. So I'm going to select Oracle here, and then I'll enter the connection credentials so I can connect. Once I have entered the connection credentials and it makes SCT, which is installed on local host, makes a connection to my Oracle database. On the left-hand panel, it shows me the tree view of my database, which I just added. Now I'll add a target. So in this case, I'll be adding two different targets because, as I mentioned, I want to move one schema into Aurora Postgres, the other schema I want to move into Amazon Redshift because I want to have some data warehouse capabilities on my database. So I'll add the connection credentials. It will make a connection, and on the right hand panel, it will show my Aurora Postgres instance from AWS. Next, I'll add Amazon Redshift. Same thing, I'll add connection credentials, and it should populate Redshift. And as you can see on the right hand panel, I also see Redshift just below Aurora Postgres. Now, next thing, I'll see all the schemas. So Chinook is the schema that I would like to map to Aurora Postgres. So I'll create a mapping. And I also have another schema called sales and sales DB schema, which is where I want to do analytics, which I am going to move to a data warehouse. And I've mapped it to Redshift. Once I have added this, as you can see in the central panel, I see both the mappings. So I have one schema mapped to a OLTP, the other schema mapped to a data warehouse. And that's what you see in the central panel, those two mappings. So once I've created the mappings, the next thing I want to do is I want to assess my schema. So what that means is I want to see the viability of my migration. I want to see how much of my schema is automatically convertible, how much of my schema would need some manual work since I'm changing the target engine or the underlying database engine when I'm moving it to the target. So here in the context menu, I'll click create report. Once I click create report, it will generate an assessment report that shows me the viability of moving my source database to a target database in AWS. So this is what the report looks like. Here you can clearly see that all my tables, constraints, sequence, how many of those are there. Since it's a simple database, that's why you see the numbers are quite low. But obviously, this can be easily scaled when you use it in your real production environment. So this report is telling me that everything is pretty much convertible to the target engine where I'm moving, except there's one object that needs some action, that needs some manual work. And now I'm going to click into Action Items tab on the top. And when I click on Action Item tabs, SCT highlights the object that caused the conversion issue. So when I click on it, it highlights it in red. And as you can see on the left panel, it has highlighted the procedure, which is sp_secure_DML. And I am looking at the source code to see exactly what object has created that action item. The other good thing is it also shows you the recommended action. So when you see the action item, what action can you take to mitigate the issue before you are migrating it to the target in AWS. Now I've looked into it. The other thing I want to do is I also want to create mapping. So I switch back to mapping view to create migration transformation rules. So SCT can apply the rules during conversion. For example, PostgreSQL converts all object names in lowercase unless they are quoted. That is why we need to create a transformation rule which convert all source schema and table names to the lowercase in the target database in Amazon Redshift. So here I'm creating, click save. I'll create another rule for the table where I want to convert it to the lowercase, save. So that's for my first mapping. Now for my data warehouse migration, I want to create another transformation rule, which is I'll select that, create a new migration rule or a transformation rule. And now again, add new rule. Here I will select the schema name. And the rule that I want to create is I want to add a suffix. So after the schema is converted, it should add a suffix of _demo in front of my schema name. And I can save it all. Next thing, okay, so when I click on the transformation, when I click on my mapping that I have created in the central panel on the top, it shows me the corresponding transformation rule that I've created for those mappings. And that's what we see on the screen. I'll switch back to the main view. Let's look at some of the more interesting things, such as I'll now convert the schema. So I clicked on the right on the context menu, and you can see on the right hand panel it has converted the schema. And if you remember, I created a transformation rule to convert it to lowercase, the schema name and the table name. So as you can see, it has converted Chinook, which is uppercase on the left hand side, is now showing Chinook in lowercase. Likewise, SalesDB demo is another schema which I moved to Amazon, which I want to move to Redshift, and it has put a suffix of _demo in front of it. So here everything looks good. Now I want to apply this to my database, this converted schema, and it applies it to the target in AWS. Now I can see all my schema, but the tables are empty. Obviously, we have not yet moved the database. So same thing, I'm doing it on Redshift. I've applied my schema. So after I have applied, the next thing I would like to do is I would like to just see how the source code has been converted when I moved it to the target in AWS. Since I have changed the engine, so the code has changed. So I can verify that by clicking on the artist under Chinook, and here it's showing me my SQL code, and on the top it's showing me on the source. In the central panel at the bottom it's showing me the code, how it looks like in the target engine. So this is what I'm showing you right now on the screen. For the view, I'm going to check the code. This is how it looks like. So everything looks good. Now I will create a DMS task because I have assessed my schema. I have applied my schema to the target in AWS. And now the next thing I want to do is I want to move my database from my source to the target location. So before I do that, I'll just save the table mappings that I had created, and I'll switch to DMS in AWS console. I can click on the endpoint, so it's showing me all the endpoints where I'm going to move the database. So here it's showing me the source, which is Oracle. That's one endpoint. The other endpoint is my destination, which is the target, which is Amazon Aurora Postgres in this case. And now let's go and create a task. So right now I don't have any task. I'll create a migration task, put the name of the task, which is a task identifier, select your application instance, and then choose the source endpoint, which is Oracle, and the target endpoint, which is Aurora Postgres. Once I have done that, I want to migrate the existing data because I've already applied my schema. I'll say do nothing. The other thing is I can also create transformation rules here, but since I've already created it on SCT, I'm just copying. So you don't really have to use the wizard. You can also copy and paste the JSON code for your transformation rule, which I had saved. And at this point, I'll say create task and switch back to SCT. So here's it showing my SCT, my DMS task, migration task. Now I am in SCT, where I'll go and I'll be able to see that same task in SCT console as well. And I'll say, okay, now it's ready to go. So I can select, hit start, and it'll start my DMS task. So here it's starting. The next thing I would like to do is, if you remember, I moved one of my schemas to Redshift, which means I want to move those tables into my data warehouse in AWS, which is Amazon Redshift. So in order to do that, if you remember in the demo, I talked about the extraction agents. The extraction agents sit next to your on-premise, your host database. And then I have to register that extraction agent to this SCT. So here I'm going to select the tables that I want to move. I'll say, so here I'm trying to register my extraction agent, provide the host name, port, which is local, test connection, everything looks good. Let's create an extraction task, and that's the status. So I'll right click on the context menu, I'll say create local task. And for creating the local task, I'm just putting the task name. The migration mode that I want to do is, there are three modes. So I'm going to select extract, upload, and copy because I want to move everything to S3 and then from S3 to Redshift eventually. Create. Once I have created the task, here it shows, I'll start the task. And as you can see, it's trying to extract, upload, copy. It's showing me all the status. Everything is green. Everything's done. All my tables have been copied to Redshift. Let's look at the DMS task that we had created before doing the extraction. And that is also load complete. Everything's good. Table statistics, whatever it has moved. So everything looks good. Everything has been moved successfully. Next thing I'm going to do is I'm going to go to my DBware console and show you on the left hand side, that's my source database. Let's see on my destination, which is Aurora Postgres. Here you can see all my tables have been successfully moved. It looks exactly identical as it looks on the source database, which means I've been able to move everything over to my target in AWS. With that, this is, again, as I said, very simple example, how I created my task, how I moved my database, how I moved my sources to data warehouse in AWS. You can obviously use it for your production workloads the way I showed you in the demo. So thank you very much for seeing the demo. Now I'll have Sam come over and talk about the Aris Global use case.
For those of you who don't know us, Aris Global is a major player in cloud software solutions for life sciences. We got our start in safety and have been around for 30 years. Regulatory is our second largest domain, and we continue to leverage our experience. Many of our EU customers are focused on IDMP compliance currently, and we are ready to help. Aris Global brought the first IDMP solution to market and participated in the original discussions back in 2015. Fast forward to today, the company has more than 300 customers across the life sciences domain. From the largest pharma to emerging companies, let us show you the path to regulatory success. Our vision is to pioneer innovative solutions to elevate life sciences and benefit mankind. To accomplish that, our mission is to build an intuitive, intelligent, and unified technology platform that transforms global health. Our customers need compelling solutions that are easy to use and help their operations. We have 4 pillars that are around our product strategy. We start with compliance, first to ensure you and your organization can meet compliance requirements. We provide continuous innovation and investment for our products and releases. We take a platform approach so data ties together. We not only help automate and improve workflows, but provide insights from the data to help inform decisions. Our culture reflects our value. At the center and most important to our customers, and exceeding their expectations. We want to move quickly to help our customers and be able to change with agility as needed. We always operate with integrity. Our spirit is to collaborate, elevate each other. Together, we could do more. Hopefully, this gives you further insights on our thought process and who we are. We mentioned the unified LifeSpear clinical platform today, but there is a larger story, 30 years in the making, about how LifeSpear empowers R&D teams to develop breakthroughs faster. Our cloud-based SaaS products support life science customers in regulatory, safety, medical affairs, and coming soon, quality. Safety case volumes continue to rise as regulations become complex and evolving as innovative and complex therapies become available, as more electronic data sources become available, including real data for us to study and to ensure patient safety. And there is an increasing need to break silos for interoperability. And as the voice of patients become increasingly the center of everything that we do, patients become more empowered. To address the industry's challenges, we are delivering a complete safety solution we view as the state of safety nirvana. A safety solution, rather, a platform, will be secure, reliable, respecting data privacy. It needs to be consistent, supported by a data fabric that would enable the smooth flow of data into intelligence. At the same time, it should give you adaptability so you can tailor your ecosystem. We are proud of our list of sample customers across global biopharma. We work with leading sponsors in the industry from a regulatory perspective, including Astellas, Vifor, Novartis, Johnson & Johnson, among others. Our customers requested access to their data managed by our platform for analytics on their infrastructure. we needed a strategy to securely replicate data from our databases into the customers' databases. We chose AWS DMS as a target solution in order to meet customers' requests. Customers required us to replicate the data from our infrastructure into the customer's read-only replica of their databases. Most of the customers used Oracle, and they had existing downstream applications that were integrated with the Oracle databases. So using AWS DMS, we were able to perform a full load of the data during our initiation process. And following that, we set up CDC to continuously replicate data with low latency from our AWS Aurora database to the customer's target databases. We placed the AWS DMS instance closest to the customer's target database to reduce write latencies, which we found through various testing and analysis on our deployment architecture. In our databases, we used schema per tenant model. And as a result, most of the customers' data were isolated to a specific schema. This made it a lot more easier for us to set up DMS replication to replicate only the specified schemas and to isolate data from other customers. We use the solution for both on-premises infrastructure when customers had their databases set up on legacy data center setups, as well as with customers who had migrated to the cloud, including AWS. We were able to replicate the data into their databases in both the scenarios. Let's take a brief look at our high-level architecture. On the left, you would see our infrastructure, Ares Global Cloud, that is located in Ireland in the AWS data center. On the right, you would see that the customer in this particular case is depicted as being present in AWS, where they have an Oracle database and downstream applications that they have already built. We found that placing, as I stated earlier, placing the DMS instances closest to the target database reduce write latency and improve the replication performance. And let's talk a little bit about the benefits that we have gained from some of this using AWS DMS. AWS DMS provided us a very seamless way to replicate data to heterogeneous databases. Currently, we support Oracle, but our plans are to extend and to support other databases from other vendors as well. We have one of the key features that we have actually used very effectively is the AWS replication monitoring feature using CloudWatch and notifications using AWS SNS services. One key feature that we used was the built-in data validation feature in DMS that helped us ensure that we were replicating data accurately into customers' databases. Last but not the least was the level of support that we received from the enterprise support team, as well as the DMS services teams, to provide us the best possible solution, especially when it came to debugging performance issues on our implementation, and to ensure that we met our customers' SLAs for data latency and replication accuracy. That is it from me. Thanks. Back to you, Vaibhav.
Thank you, Sam. Now let's look into some of the migration resources that you might find helpful when using DMS and SCT. We have a program called Database Freedom at AWS. Database Freedom is an AWS database and analytics modernization initiative. So if you have Oracle database or SQL Server workloads or any other commercial vendor databases that you want to modernize to AWS, where you want to get freedom from the commercial database licensing and use the open source technologies that AWS fully manages for you, you can look into our Database Freedom program. Here are some of the AWS database migration partners who work very closely with AWS, who are well experienced and can help you with your journey when you are trying to evaluate your databases that can be moved to AWS. They can also help you with what kind of services, what kind of open source database engines that AWS has available, where you can easily migrate your commercial database engines into AWS. Here are some of the resources. You can actually go to these links as listed on the slide. So there is a very good resource that can help you get started with DMS or SCT, how you can use those services. It can also highlight some of the features that you might find helpful depending on the type of database engine that you are trying to move from on-premises to AWS. You can also find some of our support resources, where you can also read some forums, you can read blogs on specific use cases that DMS and SCT supports. And we also have CLI support in AWS SCT. So there's a whole guide that you can go through. You can read about how to use the command line interface with AWS SCT. And overall, these are pretty helpful links. And once you go to these resources, you can find more details within these pages. Obviously, I have not listed everything, but when you go to these links, you will definitely find much more resources that are available to you based on the type of use case that you have. Thank you very much for joining us today, and I hope you have a wonderful day. Bye for now. Thank you.